Hi Nathan, hope the revision is going well and fun in the sun was nice. Right, let's have a crack at this one. So I'm going to set my diagram up first and just put it in this little area over here. So I've got two planes and I know that they're parallel. I've tried to show that in the diagram, and I know that the shortest distance between them from some point on the plane to the next one is 2. Okay. And then we're given two other points, A and B. Now, if we're given this information about the shortest distance, that's going to be the way into the problem. And I prefer thinking about this as a path diagram. I would want to go straight there and know that's a distance of 2, but an alternative route is I can go X to A to B, plus B to Y, and that's equivalent to me going X to Y. Now, the use of that is because it gives me some information about the normal. And if I've got a normal to one of the planes, it's also going to be a normal to the other plane because they're parallel. But I've got to engineer that normal generally. So it says that the X and Y components are equal. So I'm just going to call that A. And I don't know what the Z one is, so let's call that B. If I now go and dot the whole of this line with the normal, we'll get some really nice cancelling. So I can copy that, paste it, and every single thing here I'm going to dot with that normal. So if you dot something and they're perpendicular, they will cancel out. And that is what's going to happen with XA, because that line lies along the plane, so it will be perpendicular to any normal. And it's also what's going to happen to BY. So they're going to disappear. And then, after we've done that, we can take the magnitude of each side. Now, because XY is in the same direction as this normal, if we that means basically, if you look back at the notes, we can have the magnitude of XY, the magnitude of N. Okay? And that goes back to the idea that this overall rule is if you dot two things, it's equal to the magnitude of this. Because the angle between X, Y and the normal is 0, because they're parallel, dotting these two things here is the same as just finding the magnitude of them separately, because this would be equal to 1. So what that enables us to do is write out a really useful equation. Don't need a capital N there. And we can start to do some calculation. So we were told in the question that that was 2. That's groovy. And then finding AB, we can just go on and do that using this information that we've got. So AB would be B minus A, so we'll get 10, 12, 10. Okay, so we've got 10, 12, 10. And the normal that we engineered was A, B, because the X and Y had to be the same. The normal underneath, if we want to find the magnitude of it, it would be A squared plus B squared. There we go. So let's actually do this dot product. So we'll end up with 10A, 12A, so 22 lots of A plus 10 lots of b over the square root of 2a squared plus b squared equals 2. Okay, bit of cancelling there. We've got, we can divide each side by 2, which would be quite nice. So we get 11a plus 5b equals 1 over that square root. Times by the denominator. Okay, so we just get the square root of that. And now we're going to have to square each side to get rid of it. So square each side there, get 2a squared plus b squared. Ugh, okay, 121a squared, 55, 110ab plus 25b squared equals 2a. This doesn't look nice. 119a squared, 110ab plus 24b squared. Okay. So what we're going to have to do is essentially we're still trying to find like this normal, like the possible values that will work for that normal and satisfy this equation. Now it's quadratic in a sense, and wow, that is just brutal, but we're going to have to factorise it somehow. Well, it's definitely going to have A's and B's, and they're all going to be positive, so that's a plus, I guess. 119 is horrible, so I'm going to start with the 24. 110 is even, so I don't want to use the 3 and the 8. I'm going to try 4 and 6 and see if it works. And then I've got to try and find something that divides 119. Not 6, not 3, not 4, not 5, 6. 6 won't work. 7, yes. Is 49 and 70. So what's that? 17? 17. I can't. So actually, I think the 7 and 17 must be right because they're both prime. Oh yeah, so they've got to be right. Right, let's check and see if I was lucky with the 4 and the 6. So that, and then, oh, what a touch. Okay, so I've just been lucky there, basically. But if I had, yeah, the 7 and the 17 mean that I'd have to persevere trying to do different combinations of like the 24. But that's just hard. That's just a hard factorisation. But what enables us to do is say that this equals 0 or that equals 0. So 7a has to be equal to this. Now, we could pick lots of solutions that would balance that, but if we pick the lowest value, a would have to be 4 and b would have to be -7. Now we could make them the other way around. We could pick like -4 and +7. So that would still work. But that means that one solution of my normal is 4, 4 -7. And then a similar technique here. I'm just going to do it the same way. So I'd have a would be equal to 6, and then I'd have to have b being equal to -17 to balance it. So my other normal would be that. This is really hard, this question, blimey. Yeah, so we get to there, and now that's the hard work done, because we want to find the acute angle between the two possible planes. Now this is just like a standard method. We're going to use this formula, so copy that, because that's how we find the angle between any sort of vector. And we've got two planes here, if I just draw a separate picture, and two normals. Now what we want to do is we're going to use the two normals and find the angle between them. And that would be this angle, which would actually be the same as the angle here between the planes. Now if that works out to be obtuse, we can just do 180 minus, but let's just see what we get. So let me just move that diagram over. So we've got 4, 4, 7. We're going to dot that with this, and then we're going to find the magnitude. Let's label that 1 and 2. We're going to find the magnitude of those two things, and then it's going to be cosine theta. A bit of number crunch. 24, 24. 7 times 17 was 119. How do you know what? 167. And then we've got to find the magnitude of both of them, and we're actually going to divide by that. So oh, that's nice, 81. So that's 9. 161 square root 19. Nice. Okay, so that's going to go into inverse cosine. Let's do that. 167 times 19. And I've got, there you go. So we do actually straight away get the acute angle. So I've got that. If it was the obtuse one, I would have done 180 minus and got it, because it basically forms this kite, and we've got two right angles here, and this angle have to add up to 180. All right. Yeah, it's hard, Nathan. I think that factorising bit in the middle is brutal. But then your mental arithmetic is much better than mine. Yeah, hope that helps, and yeah, good luck keep going with the rest of the revision.